We are very glad to show you some tech demos of our Cog-DNA system, a wayfinding system that helps reduce cognitive load of firefighters in the line of duty. In certain tasks such as search and rescue, firefighters need to rely heavily on huge amount of information to navigate. So we use different approaches to measure their cognitive status and dynamically adjust the information we are giving to them to help reduce the load in information processing. The first method we use is called Wayfinding. This is a brain measure device. The yellow dots you see here send infrared light into the brain, about 2 to 3 centimeters deep, very safe. The blue dots then measure how much light is absorbed in certain areas of your brain. So that shows the oxygen level consumption. The second method we use is this eye tracker embedded in VR glasses. So it tracks your gaze focus, so how fast you move your eyeball, that's an indicator of your cognitive load. And also it tracks how much your pupil is enlarged, that's also a strong indicator. Now let's talk about what kinds of wayfinding information are included in the Cog-DNA system. The most commonly used one is the route information. It tells the firefighters to turn left, to turn right, the red path to the final destination. Cog-DNA also includes the landmarks guidance, showing you the signage or some plants in the building that tells you where to go. We also consider, of course, the maps. That's definitely one option, very common option for firefighters. We also consider some futuristic solutions, such as this augmented reality for wayfinding, a floating arrow in the air pointing where to go, and also this very interesting haptic suit. So this haptic suit has 40 vibrators. It can generate a vibration in the right direction. So you just basically move your body and move the vibration to the front of your body so you know where to go. In the next video, I'm showing you that I was using the haptic suit. So I was standing in the middle of 4 walls. I couldn't see what's going on outside, but the person was running outside. So I only relied on this haptic suit and rotated. See that the right arrow that was pointing to that person very accurately. So in the next video, I'm going to talk about how we measure cognitive load. The first method is the eye tracker. So I'm going to show you a tech demo we recorded before. Enjoy that. This video shows a real-time cognitive load tracking system using the pupillary size of a person. As you can see, the upper one shows the real-time pupillary size, and the lower one shows the luminance, which is how bright the environment is. We calculate the RGB value of each pixel inside this VR goggle and convert that into the luminance. And we have a formula to remove the light response effects. So the residual shows the pupil size change driven by the cognitive load. As you can see, when this person moving around, the luminance is changing, the pupil size is also changing accordingly. Alright, now we just ask this person to stare at the same place. And as you will see in a moment, the luminance start to stabilize. Now we ask this person a very tricky question, 133 times 55. Now we can see the luminance stays the same, but this person's pupillary size just increased dramatically, around 20%, and start to stabilize. Like I mentioned earlier, we also use Wayfinding, a brain measure device to track the oxygen consumption level in different areas of brain. As you can see here, we track 24 areas, and the red color shows more oxygen consumption. The blue color shows more carbon dioxide. So this video shows a person was using the system to navigate in a virtual building while we are tracking his brain activity. You see the flashing is really fast. It's all because of his moving so fast. But we use the mathematics to calculate the trend of that. Now you see the pupillary change of this person after removing the effects of the lights. You see the sudden drops, that's the blinks. Blinks is also a very interesting indicator of the cognitive load. Now we see that. The system also has been tested on firefighters. So we really appreciate the collaboration of Brand Fire Department in Texas. So this one shows this firefighter was using our system and to find the 3 missing people. And we also adjusted the visibility. So this is affected the visibility, and the firefighter was using landmarks, routes, maps, haptic suit, and augmented reality, different solutions we provided while our students were documenting his eye tracking, pupillary size, and also brain activity. Now what you see is the playback of this person's data. Here we show the gaze focus. You see the moving dots. That's where this firefighter was looking at. And you also see the trajectory of that. The green lines you saw was the movement trajectory of this firefighter. So we document all the data in an Excel spreadsheet. So for fire chief or trainers, you have a chance to download this person's data and see what's going on, and maybe can tell the firefighter where he or she should improve. But of course, this is real-time system. So by tracking the trajectory, by tracking the pupil size, by tracking the brain activity, and we can adjust the information we are giving to the person. Thank you, and we welcome all the questions.